Good morning. Can you hear me?
Yes, ma'am. Good morning po.
Now, I understand there are new students joining us today. Now, for those who were not able to attend the first orientation day, may we ask these students to quickly introduce yourselves and your current affiliation, please, especially the new students. Can we begin with our foreign students? Do we have any language interpreter for our foreign students, or do you speak English? All right, Mr. Vincent, can you quickly introduce our foreign students? Just their names and probably if they are affiliated with any organization or institution or university, so that we can also get to know them a little. Okay, thank you. All right, so I just read one chat message from, how do I pronounce your name? Ken Ken Chow. Am I pronouncing it correctly? So you are an undergraduate student, major in clinical medicine. Okay, so you are a full-time student. Do we have other foreign students? Please check also and make sure that you are enrolled in the correct course with the correct course code, especially for our foreign students. So I understand we have some limitations in our uh, mode of communication, right? So we have another new student in the person of Ning Huang. Okay, so all right, so you have worked in a laboratory, clinical laboratory in the past 10 years. Okay, so how about the others? So I think there are five or six new students. Now, while we are waiting for the, all right, okay, Sir Vincent. Okay, there are currently four. All right, so only four are left. Mr. Vincent, may I know who are those two students that dropped out? Dropped out in the earlier parts of the semester for this course. Okay, so there are only four students left, and these are their names. Okay. So how about Zheng Yu? So can we hear something about your affiliation? Are you working or you're a full-time student? So I already know Miss Liu Yun, and then some information about Pian Pian and Huan Ying. All right. Okay. Thank you for this, Vincent. So just one more. So how about Zheng Yu? Is she a full-time student also? Oh, sorry. It's a he. Okay, he is also a full-time student. Now, for our local counterpart, I'm seeing new names. Welcome to the class. Miss Maria Gabriela Grace. Can you quickly introduce yourself, your affiliation?
Hi po, good morning. I'm Maria Gabriela Grace Frances po. You can call me Gabby for short. Ah, I work po in Cardinal Santos Medical Center, ma'am.
So it's a tertiary private hospital, ma'am.
Yes po,
For how long are you affiliated with this institution?
for 5 years, ma'am.
So quite a good number of years. Okay, so welcome to the class. How do we call you? How do we address you? What's your nickname?
Gabby, ma'am.
Okay, Ma'am Gabi. Okay, thank you for the information, Mr. Correct me if I'm wrong, Mr. Yuzeng. So you are an undergraduate major in medical laboratory technology and also a working professional for 8 years. Welcome. Now, I have previously discussed to the class the content of the syllabus. Okay, so that was 2 weeks ago. For those of you who were unable to listen and see the syllabus, okay, so I will be sharing the syllabus to your emails. I just need to check the final class list, the updated version that will be provided by the graduate school office. Okay, so after which I could now send the syllabus to all of you. Now, also previously, I have assigned Mom Sol. Are you here, Mom Sol? Right. So you were able to make a list, right? So you made a list of the different topics that you will be presenting in the succeeding weeks. Now, you also mentioned that some of the foreign students, except Miss Yun, was not able to coordinate with you, but Sir Vincent was able to get in touch. Okay, now I just need to know the topics that were selected by the rest of the foreign students that we have, because as of the last email I received, there was no response from the three students, Mr. Vincent. Okay, so as to the list of the topics, I already, you have what, ma'am? Ma'am Sol? You have emailed the complete list? When was that? I'm checking my email now. This one is last February 12th. Right, so based on the list that you provided, so there are five topics for red blood cell disorders, and then two for white blood cell disorders. We have five for platelet disorders, and then there are six students with no topics yet. So all of them are foreign students, but we need to update the list because, as mentioned earlier by Mr. Vincent, so two out of six dropped out. Okay, right. So I need to get the list of the topics for the foreign students. So Mr. Vincent, will you send to me the list of the topics that will be presented by the four remaining foreign students, so that we will know there will be no overlapping of topics. Okay, Ma'am Sol, please do. Now, for those who are asking, so last week was the 59th founding anniversary of TUWA, and there was a webinar or some activities done online, and then I've asked you to log in and register and attend the activity. So I have also received, okay, your emails providing the proof of attendance for the said activity. And for today, I'm going to provide a quick overview lecture of advanced hematology, and then we will be finalizing the presentations that you will be providing.
Can you hear me?
Yes, ma'am.
Now, who is screen sharing?
Severe, ma'am.
Okay. Right, so can we proceed to slide number 2? right? So I hope this diagram is still familiar to all of you. Okay, so in the context of hematology, okay, we are always interested about processes. Okay, so processes that are either they are permanent or processes that are subject to changes. Okay, now what are these processes? Okay, so the first one is what we call as the genesis. Right, so the genesis or creation and development. Okay, so we know that in the context of hematology, there is a developmental there are developmental series taking place such that from primitive stages these elements will transform and become mature functional elements. Okay, another process is death. Okay, because we know that there is a certain life cycle, okay, or lifespan of each of these cellular elements. And then another is renewal. Okay, so because there should be some form of replenishment. So if one of the elements die, it must be replaced eventually to ensure the overall functionality of the body. Okay. Now, in all these things, there are several factors. So these come in the form of micro and macromolecules. Okay, such as the proteins, you have the ions, okay, you have the enzymes, you have the acids, etc. That dictate or determine how these processes will proceed from the start of the introduction of the proper stimulus. Okay, so you know that, for example, okay, what is the stimulus for red blood cell production? Can anyone answer? What is the external stimulus that will trigger red blood cell production? Anyone?
Ma'am, blood loss.
Another underlying reason, perhaps. So the number one stimulus is what? It starts with letter H. Sir Pax, are you saying something?
Hemorrhage.
No. One word?
Hemorrhage.
Okay, so yeah, so Ma'am Sol and Ma'am Evir. So hypoxia is the stimulus. Okay? So the entire body needs oxygen supply. Okay? So if there is hypoxia, okay, a state of diminishing oxygen supply in the tissues of the body, so that external stimulus will trigger the production of your red blood cell. So it is not enough that there is a stimulus, right? So upon the introduction of the proper stimulus, okay, comes the next step, which is the process of recognition and binding up so that activation of the specific molecules, okay, will be achieved to get the desired endpoint. So there may be two or more possible sequelae. So if there is stimulus and then there is a recognition that the stimulus is there, so it will activate your molecules. And what are the possible sequelae or consequences? So one is creation. Okay, so the creation will be creation of something that is normal or creation that is something pathologic or abnormal. Okay, so as in the case of cancers. Okay, another possible outcome is repair. So if the stimulus is harmful, for example, the body will have its own way of recognizing, activating the molecules, and then repairing whatever is damaged. Okay, so that the residual damage will almost become very insignificant, or the repair will make the tissue or the cell as good as new. And then another possibility is death. Okay, now death is an irreversible process. Okay, and we know that. Okay, Now, in this particular figure, okay, so this is actually an overview of the niche or the HSC. So, what is the HSC, by the way? It's an acronym being used in hematology. So, anyone?
Hematopoietic stem cell.
Okay, hematopoietic stem cell. Okay, so this one shows you the schematic overview of the HSC niche and the fate decision of your lineages. So you are still familiar with the different blood cell lineages during the period of hematopoiesis. So along with this, the importance of the different major transcription factors and cytokines involved. Okay, so there are activated molecules so that the development will proceed. Okay. Now the niche or the HSC niche consists of your endosome. So are you still familiar with your histology? So endosome, and then you have regions that are highly vascular. Okay. And these endosome and vascular regions contain your several cell types. Now within the endosome, we have your osteoclast and osteoblast. Okay, so do you still recall the importance of these structures? The osteoclast and osteoblast, do you still have memory of the significance of these cells in blood cell development? Anyone?
They are for bones, ma'am.
Okay, so what about the bones? What is the connection between the bones and the blood cell production?
Since blood is actually produced in the bone marrow, so the bone is really essential in the production of RBC.
Okay, so you have the bone forming cells. So these are immature cells. Okay, these are precursor cells. Okay, very important structures that will give rise, okay, to blood forming bone marrow. Okay, so it has to be done in a perfectly timed manner. Okay, so that other cell types will be able to support, okay, the vascular portion. Now, this time, the importance of the vascular region, this is where your mesenchymal cells, okay, the stromal cells, okay, which include also your HSC and other precursor cells are anchored within. Okay, so it's a combination of many cellular types. Okay, so you have to put together the endosome and the vascular region so that you will be able to have your blood cell production. Now, the hematopoietic lines or lineage will undergo maturation. Okay, and there must be a balance between the vascular and the industrial region. Okay. Now in the process, some of these HSCs, okay, they either go apoptosis. So what is apoptosis?
Program cell death, ma'am.
Okay, so yes, so apoptosis is a programmed cell death. No matter what happens, this particular cell will die. Okay, so it will enter senescence and it will die. Okay, so that is how organized, okay, blood production is. So they will enter the period of senescence. They will undergo oxidative stress or DNA damage. Okay, and it will trigger more. It may or may not trigger more apoptotic pathways. Okay, now, under physiological status, okay, so some molecules become activated, okay, and these are you have your reactive oxygen species, okay, you have your soluble proteins such as your interleukins, you have your TPO, and then you have your GCSF, which will give rise to common myeloid progenitors. Okay. Now, review of your hematology. What cells originate from common myeloid progenitors? Anyone? You have two lineages, right? You have the myeloid lineage and then you have the lymphoid lineage. Now let's go to the common myeloid progenitors. So these common myeloid progenitors give rise to,
The WBC, ma'am.
again,
White blood cells.
what type of WBC?
The neutrophil, eosinophil, and basophil, ma'am, includes the monocyte too.
Okay, so you have your granulocytes, right? So you have your granulocytes, including the neutrophils, or, your polymorphs, your eosinophils, you have the monocytes, and then you also have the basophils. On the other side, so you have the common lymphoid progenitors. Now, under the influence or with the influence of interleukin 7, okay, so specific molecules are also activated, okay, and in the process, question, now what uh, arise from your common lymphoid progenitors? Anyone?
The lymphocyte, ma'am.
Okay, so you have your lymphocytes, so you have your T and your B lymphocytes. Now, question, how about your erythrocytes and the platelets? What are the progenitors? So this is just a review. So what are the progenitors from which your red blood cells and your platelets originate?
The megakaryocytes and the erythroblast.
Now, from what progenitor?
CMP, ma'am.
Common myeloid.
Okay, so you have the common myeloid progenitors. Okay, so this is from where your RBCs and platelets, okay, after their maturation, okay, so they become your platelets or thrombocytes. Okay. Now, erythroblast that was mentioned earlier forms part of the developmental cycle of your RBC. Okay. Now, the mesenchymal stromal cells that I mentioned earlier. So these are your MSC. Okay. Now, what are MSCs? They are heterogeneous. They are non-hematopoietic. Okay. They are fibroblast-like cells that can differentiate into multiple lineages. So non-specific. So what are these multiple lineages? Okay. That arise from your MSCs. These are your chondrocytes, your osteoblast, myeloblast, and your adipocytes, among others. Okay. So what we are emphasizing in this diagram is that the in the development of the different cell types. Okay. So some of them would arise from single or common progenitors. Okay, before they differentiate into mature types, okay, of cells. Now, before I proceed with the next slide, how about your natural killer cells? Where do they come from?
They are lymphocytes, ma'am. They come from lymphocytes.
They come from the common
Lymphoid.
lymphoid. Okay, common lymphoid progenitors. Okay, okay. Next slide, please. In this picture, okay, so you see the role of the other organs of the body. Okay, so earlier we mentioned about the role of the vascular and the endothelial niche, and then we also mentioned about the presence of stromal cells that provide your progenitor cells. Okay, so that differentiation can take place. Now, on the other hand, okay, so looking at this diagram, okay, can anyone provide an idea on how the kidney will play a role in the production of blood cells? Okay, so can you look and analyze at this picture and tell me what is the role of the kidney? Okay, so earlier we mentioned about the bone marrow, right? So we all agree that the bone marrow is where it is the site of blood cell production. Okay, so it contains non-hematopoietic and hematopoietic lineages. Okay, now how about the kidney? May I hear it from anyone who would want to interpret this particular diagram? And why is it that, for example, among persons who have kidney failure, they appear as anemic, right? So we all know clinically that a person with kidney failure, for example, would also present as someone who has anemia. Okay, if we look at the blood picture, if we analyze the CBC results of the patient, now can anyone please share their review of what the role of the kidney is? Or should I be calling names instead? But I prefer volunteer. Sir Pax? Yes.
Yes, ma'am. Uh, in the diagram, when the body's is low, so the kidney is actually signaled by the brain to release erythropoietin, which stimulates the production of uh, red blood cells. So when the erythropoietin is released, the bone marrow starts producing RBC.
Yes, Sir Peter. Can you add up to the to what Sir Pax has just discussed?
In cases, ma'am, of hypoxic conditions such as low blood pressure, which is usually detected by the kidney, wherein abnormal renal blood flow would affect it. The kidney would produce erythropoietin, which is the hormone that would cause the production of RBCs. What erythropoietin would do is that it would act on the bone marrow and it would cause the bone marrow to start the production of the red blood cells. and then these red blood cells would somehow correct the problem with the low oxygen supply.
So it is also a compensatory mechanism. Would you agree, Sir Peter?
Yes, ma'am.
So in depending on the status of the blood flow, okay, the oxygenation status of the body, okay. So the kidney will also aid, okay, in the development particularly of your red cells, okay. So upon the action or the production of your EPO, okay, which is also a hormone, so it's a regulatory hormone that will trigger your bone marrow to produce the required red cell mass, okay. So at some point the kidney also regulates the total hematocrit, okay, level of the body, okay, because you need to achieve the balance, okay, of atmospheric oxygen, cardiopulmonary function, maintenance of the blood volume, okay, hemoglobin concentration of each cell, and the oxygen affinity. Okay, so that's why if there is kidney problem, okay, so there is also uh, downregulated EPO production, okay, and there is insufficient um, bone marrow production of your red cells. Okay. Now, next slide, please. Now, this diagram is actually a cross section. Okay, it's a cross section of the EPO signaling pathway. So, since nowadays we are dealing more of molecular diagnostics, okay, so it's also important for us to know the details of how signaling pathways are being regulated, okay, like this when it comes to your EPO, okay. So there are three main EPO signaling pathways, okay, highlighted in this diagram. So you have a positive signaling associated with a particular molecule known as your STAT or STAT5. Okay. Now the STAT5 becomes activated, okay, and it binds to the other molecules. So you have there the different labels. So if you look at the middle of the picture, so you have those molecules with the Y letters, Y343, 401. Okay, do you see that, sir? In the middle of the EPO molecule. So you have the binding units. So you have the different 343, 401. Okay, and this is where the stat will bind. Okay, now once they bind, okay, it will activate now another pathway. Okay, so the other pathway will be activated. Okay, and in effect will also activate other proteins. Okay, so if you look at the picture here, okay, so you have the proteins Y429. I hope you can see the. Is it wide enough? Can you clearly see the names of the molecules?
Yes, ma'am.
So another binding process, okay, will take place. Okay, activating your MAPK pathway. Okay, and then if you look at the bottom part of the picture, so you have a negative regulation. So earlier I stated about positive signaling, right? So if there is a stimulus, so it will signal, okay, the EPO production through several binding mechanisms, okay? But then there is also what we call as negative regulation, okay? Why is there a need to have a negative regulator? What do you think? Based on logic, Is there a need to downregulate also? Yes or no, and why? Can the EPO production and proliferation become constant, or is there an endpoint? So this is a very practical question, so that we can understand what is meant by negative regulator or negative regulation. If there is an activator, there is also a suppressor, right? Yes or no?
Yes, ma'am.
So after EPO is produced, it's been stimulated, okay? Binding already occurred, okay? Proteins were already expressed, okay? And then you produce the red blood cells, okay? There is always an endpoint, okay? There is only so much that the body can take, that by nature, negative regulation must be expressed, okay? Otherwise, it will just continue to express your EPO, and it will not stop, okay? So this is usually the mechanism for those patients that have malignancies, okay? If the negative regulation is not properly processed, okay, so the consequence is possibly malignancy. So there is no activation of your suppressor suppressor molecules like your cytokines, for example. Okay, so there should be an endpoint. Okay, now one of your tasks will be to identify. Okay, so ma'am Evir, you can share this PowerPoint with the class. Okay, so to further understand this picture. Okay, so what I want you to do is look at the molecules. Okay, provided here. So you have your JAK. Okay, JAK stands for Janus kinase 2. Okay, and then you have you're also familiar with TPO. So TPO is thrombopoietin. Okay, and then you're familiar with EPO, which is erythropoietin. Okay, now I want you to look up for the meaning of these different molecule acronyms shown here, and then what are the functions or the roles of these particular molecules. Okay. Now, which one is a suppressor? Which one is a regulator? Okay. Which one is responsible for cell proliferation, apoptosis, etc. Okay. Any question? If there is a mutation, for example, in one of these molecules, that the effect can be very significant already. Okay. Any questions so far? So in short, the molecules shown here, some of them are responsible for negative regulation, some of them are responsible for suppressor function, okay? Some are mediate EPO production. Some also are responsible for apoptosis, okay? Then some of these molecules are act as receptors, okay? So please find out the roles of these molecules shown here. Okay. Now, can we go to the next slide? Now, other than the kidney, okay, so we also know that the thyroid is also an important organ, okay, that provides a feedback mechanism based on this picture. Can anyone quickly give us idea on how the thyroid becomes important when it comes to regulation of the blood function? Anyone? Any idea, sir and ma'am? So it's not just the kidney that's important when it comes to hematopoiesis, but also the thyroid. Looking at this diagram, so what happens when a person has a thyroid disorder? Will that person possibly exhibit anemia? Yes or no? Yes, sir, Peter.
Ma'am, the relationship of the thyroid with the uh, hematopoiesis is that thyroid hormones, specifically T3 and T4, are responsible for maintaining homeostasis. So when you say homeostasis, ma'am, this is wherein organism would adjust itself according to the surrounding conditions. Now, let's say that your body has normal body conditions, your body would have normal T3 and T4. But let's say that you went to a cold region, you would have now a disturbed homeostasis. This disturbed homeostasis will cause a decreased T3, T4 concentration in your blood. This would now stimulate your hypothalamus to release your TRH, or your thyroid releasing hormone. Now, TRH would now stimulate the anterior pituitary to release the thyroid stimulating hormone. And TSH would now cause the thyroid gland to release T3 and T4, restoring the normal homeostasis in the body. Basically, ma'am, it would allow the a person or an individual to adjust and maintain balance within the body.
So very well said. So the role of the thyroid gland, okay, the thyroid organ, okay, very important physiologically, okay, because they also have some regulatory function in terms of hematopoiesis that takes place in the bone marrow. Okay, so the in particular the T3, for example, okay, uh, studies show that the T3, okay, is a requirement or a prerequisite for normal B cell production in the bone marrow. So therefore, it's capable also of regulating your pro B cell. Okay, so if a person has a thyroid gland dysfunction, so patients would also present as anemic or anemia. Okay, and also a person with, for example, you have hypothyroidism. Okay, the hypothyroid status of the patient will also affect the level of the iron, the vitamin B12, and your folic acid. Now remember, these are essential vitamins, okay, and minerals, okay, that aid in the maturation of the cells. Okay, now which leads us to the next question. Okay, so if a person who has hypothyroidism would have low levels of iron, low level of vitamin B12, low level of folic acid, what do you think? What kind or what type of blood cells will be affected? What do you think? Is there some sort of anemia or some kind of anemia that's associated with a deficiency in vitamin B12 or in folate or in iron? So what anemia? Do you still remember what anemia, what do we call the anemia? Which is a macrocytic, which would have your macrocytic cells.
Pernicious anemia, ma'am, or megaloblastic anemia.
Okay, so you have your megaloblastic anemia, so you have your pernicious anemia. Okay. How about for iron? It's very easy. Anyone can answer.
Iron deficiency anemia.
Okay, so you have your IDA. So you see the effect of dysfunctional thyroid, okay, will also lead to other forms of anemia. That's why it's very important to maintain a euthyroid state. Okay, otherwise it will lead to other abnormalities. Okay, so not just your red blood cells, but also your lymphocytes, because I mentioned earlier that the T3, for example, also regulates your normal B cell production. So for those patients with low levels of T3, okay, or abnormal levels of T3, would have some problem also with their B lymphocytes, or probably since B cells, okay, would give rise to your plasma cells, okay. So these patients would have, or they are more susceptible to infections, okay. Now, next slide, please. So this is a highlight of the previous slide that I showed earlier. Okay, so we need to also to highlight the role of the MSC or the mesenchymal stromal cells seen here, because they are known to possess immunomodulatory activities. Okay, so they are also capable of stimulating repair and regeneration of any diseased or any damaged tissues or cells. Now, these are basic properties of your MSCs, okay? So that they have important applications also in your hematopoietic cell transplantation, okay? Now, HSCs, on the other hand, so we mentioned them earlier that these are stem cells that are capable of giving rise to other blood cells. Okay, so this process is called hematopoiesis, and then your HSCs give rise to your several lineages. Okay, specifically your myeloid and lymphoid cell lines. Okay? Now, I'm also showing here on this slide some examples of the regulatory or modulatory proteins, okay, that become activated in the mesenchymal part. Okay, so that repair and regeneration can take place. Okay, so take note of these different molecules and their functions. Okay, so looking at the examples here, so you have regulators of intracellular signaling pathways. So you have molecules that maintain the blood cells in the niche. Okay, so there are molecules or cells that also aid in recovery in vivo. So like your EPC, so function for reconstitution and hematologic recovery in vivo. So this particular molecule is also a candidate for cellular therapy to enhance your hematopoiesis. Okay. The TPO is also very familiar to you. So it stimulates the formation of your megakaryocytes. And then you have the angiopoietin 1, which regulates your endothelium, okay, for survival and maturity, as well as stability. You also have the JAG or Notch. Okay, so these are receptor molecules, okay, that are expressed on your clusters of differentiation 34 positive, 34 plus hematopoietic precursors. Okay, and these are expressed on the stromal cells of the bone marrow. And then you have your SEF, which is also important in preserving the viability of the HSC and the progenitors. Okay, so they also influence the entry into the cell cycle, facilitating proliferation and differentiation. Okay, next slide, please. Right, so more examples of molecular signaling and regulatory pathways for your HSCs. Okay, so you have the cells developing and leaking from your bone marrow going into the bloodstream. Okay, so remember that after the time is right, okay, so the bone marrow will now release the cells into the bloodstream. So the cells that are released in the bloodstream should be in the mature, most able form of the cells. Okay, now, but before they are released, okay, there are certain molecules also involved. Okay, like for example, okay, if something happens in the bone marrow and the cell being produced is dysfunctional or it's useless, okay, there is also a way of eliminating these dysfunctional or useless cells. Okay, so there is a modulator. So this is your BAX, which serves as the important modulator of apoptosis. Now, even within the bone marrow, apoptosis is also happening already. Okay, it's a way of regulating so that those cells that are released into the bloodstream are only those that are functional, okay, and distinct. Okay, so most of the molecules shown here in this picture are regulators, upregulators or downregulators of apoptosis. Okay. Now, if there is an imbalance in the levels of these proteins, okay, like for example, if there is um, reactive oxygen species, okay, so these regulate the differentiation, okay, self-renewal and the balance between dying and proliferating. So if there is an abnormally high level of your ROS or reactive oxygen species, this will lead to advanced aging. Okay. Okay. Next slide, please. Now we proceed to concept mapping. So to begin with, so I know that you're already familiar with hematological disorders, right? So what disorders can be identified based on the following categories. So if you're going to divide the hematological conditions, okay, that we know of, okay, some of these are would fall under the category of hereditary, and some are actually acquired. Okay, some of the disorders are benign, while some are malignant. Some are outcomes of either absence or suppression, or it could be a consequence of overproduction. So you see, you can readily categorize the hematological disorders. Now, I would want to give you probably 10 minutes, okay, to just give some examples of these disorders, okay, depending on the category. Okay, so you can repeat the name of the hematological disorder, but we want to emphasize okay, that in order to organize, okay, we can categorize these disorders. Okay, so you have three groups. You have three groups. Okay, so hereditary, acquired, benign, malignant, and then absence slash suppression or overproduction. Okay, so let's make it an individual output. So I will give you 10 minutes to make a list of the disorders that you still remember under the hereditary, under acquired, etc. Okay, so time check is 9:21. So we resume at plus 10 minutes, 9:31. And then I will pick a presenter. Okay, any question? This is very easy. So it's just memory recall. So you just need to list down the disorders that you know would fall under hereditary, what are those that are acquired, benign, malignant, etc. Okay? Questions, clarification? Okay? If there is none, so you may proceed with listing down these hematological disorders and be back after 10 minutes. Okay? Thank you. All right, so it's already 9:32. So I posted a message in the chat box. So you need not enumerate or list all. Okay, so given the very limited time. Okay, so may I ask Miss Gabby to kindly share your list for hereditary and acquired hematological disorders?
Yes, ma'am. For the hereditary and acquired blood disorders, I listed iron deficiency anemia, aplastic anemia, sickle cell po, and thalassemia po.
Now, which one would fall under the hereditary and which one is acquired? Can you
Uh,
specify?
for hereditary, ma'am, iron deficiency, aplastic anemia, and thalassemia po can be classified in hereditary disorders. And in acquired,
Okay, so we go first to the hereditary.
okay po.
Any comment from the class? So she gave three examples. So your examples are thalassemia. What's the other one? Aplastic.
Yes po.
And then the third one is
Iron
IDA.
yes po.
Okay, so any comment, sir and ma'am, with regards to the list under hereditary? Any comment with regards to the list? Okay, so do we all agree that thalassemia is a hereditary disorder? Yes or no?
Yes, ma'am.
Yes, ma'am.
How about aplastic anemia?
Acquired, more like acquired siya, ma'am.
There's a case of aplastic anemia, ma'am, that is congenital, known as the, if I recall, diamond black anemia. So it's a possible hereditary.
So is there a kind of aplastic anemia that might be acquired?
Yes, ma'am.
Okay, so in short, for the list of, if we're talking about aplastic anemia, it could fall under both under hereditary and also under acquired. Okay, so it depends. Okay, now yes, so there is a genetic predisposition. Okay, with regards to aplastic anemia. So this is the Fanconi's anemia. Okay, or what was mentioned earlier. So the black diamond. Okay, so how about the aplastic anemia? Can the acquired type of aplastic anemia? So do you recall any factor involved in aplastic anemia that's acquired?
Ma'am, aplastic anemia can be acquired through radiation, ma'am.
Okay, so what
Exposure
else?
to radiation or
Okay,
uh, some drugs po.
so it some chemotherapeutic agent can lead to aplastic anemia. Okay, correct. Okay. So with Jason, now the third one. So iron deficiency anemia. Okay. So any comment? So according to Miss Gabby, so iron deficiency anemia or IDA falls under the hereditary hematological disorder. Any comment?
It can also be acquired, ma'am. Iron
Okay.
deficiency anemia. If, like for example, to us females, if we don't have enough iron during our pregnancy po.
Okay. So for women of childbearing age, okay, so there is a known possibility that IDA, okay, or iron deficiency anemia may be acquired. Okay, so if usually the most common um, reason, okay, why there is acquired IDA, it's because of diet. Okay, so another is, for example, physiological factor such as pregnancy. Okay, heavy menstrual periods, okay, can also become factors for the development of the IDA. Okay, now is there such a thing as hereditary iron deficiency anemia? Yes or no? Is there a possibility that a person who was previously diagnosed with acquired IDA will not respond at all to iron treatment? Is it possible?
Yes, ma'am.
Okay, so there is also a recessive type of hereditary disorder. So this is the iron refractory IDA. Okay, so it still falls under the IDA, but in a patient who has the hereditary IDA, okay, despite giving treatment, okay, iron supplements, the patient will remain resistant to it will still become iron deficient, okay, even if treatment is already given. So in that case, there is a possibility that the IDA itself is hereditary. So there might be a mutation in a particular gene, okay, responsible or having the mutation so that there is no proper response to treatment. Now, however, between the two kinds of IDA, so the acquired type is more common, okay, and the genetic type is rather rare, okay. But yes, we agree that it could be uh, genetically predisposed, okay. How about thalassemia? So there was mention about thalassemia. So we said that we all agree thalassemia is hereditary, okay. So do you still recall the different Thalassemias. What, by the way, is a thalassemia? Miss Gabby?
Thalassemia, ma'am, is a genetic disorder when there is an absence or mutation in the hemoglobin, ma'am.
Which part of the hemoglobin?
Globin.
Okay,
Globin chains.
so globin chains, okay? So there is a mutation, okay, of the part of the globin chain, okay, such that the thalassemia is becomes apparent. So it follows a pattern of inheritance. It depends on the number of genes, okay, that are abnormal. Okay, so there are four types, if you still recall. So there's a carrier type, there is a major, there's a minor type of thalassemia. Okay. For the acquired, Ma'am Gabi, did you mention examples of disorders under acquired category?
Uh, same same disorders, ma'am, but I included sickle anemia. I disregarded po thalassemia, ma'am.
Okay. So under, can we hear it from the others? What hematological disorders did you list down under the category acquired? How about Ma'am Earl?
I actually, ma'am, I have in my hereditary and acquired are the acute yung mga AML, CML, the non-Hodgkin lymphoma, the Hodgkin lymphoma, and the myelomas. The chronic myeloid leukemia, acute lymphoblastic leukemia po, and the chronic lymphocytic leukemia. That's that.
So these are these under the acquired category?
Hereditary po.
Okay. For the acquired,
I I don't have a list for acquired.
okay. Can we probably hear it from the other students? Yes, yes, Sir Kenneth.
So sa acquired, ma'am, I listed aplastic anemia, hemolytic anemia, megaloblastic anemia, dengue, polycythemia vera.
You have polycythemia vera. What's the first one that you mentioned? Hemolytic anemia. Okay, so
Aplastic,
also a very good example. The other one is,
aplastic anemia.
okay, so yes.
Megaloblastic anemia.
Okay, so megaloblastic anemia. So megaloblastic anemia is acquired because of deficiency in
Vitamin B12, ma'am, or folate. Vitamin B12 and folate, sorry.
okay, okay. So good examples. Now we proceed to the next category, benign and malignant. So I assigned it to Sir Pax. Are you here, Sir Pax?
Para na-disconnect si Sir Pax mo.
Na-disconnect si Sir Pax. Okay. So let's call on another student. You're here, Sir Jem.
Yes, ma'am. Good morning po.
Okay, good morning.
Ma'am, for benign and malignant po, ma'am, no?
Yes.
For the benign, ma'am, I have iron deficiency anemia, megaloblastic anemia, pernicious anemia, plastic anemia, and thalassemia po. While in malignant, I have polycythemia vera, chronic lymphocytic leukemia, acute myeloid leukemia, and chronic myelogenous leukemia po.
So those cancers of the blood, okay, so would all fall under the malignant disorders, okay. So the leukemias in particular, okay. Now those benign disorders are those that do not are no longer induced for overproduction or overproliferation. So no tumors, okay, involved. Okay. Now, very good examples, Sir Jem. Okay. How about the third one? So I chose Miss Yun Liu. Are you here? Can you please share with us your list of hematological disorders under the category of absence or suppression, and then another category due to overproduction? Let's wait for Miss Yun. Okay, so right. So based on the chat, okay, so absence or suppression can be seen in the following conditions. So you have thalassemia, IDA, idiopathic thrombocytopenic purpura. Okay. Can we ask Miss Kyun, why did you choose ITP under the absence or suppression category? Can you further discuss your answers, Miss Yun? Just some short explanation, okay, with regards to your answers. Okay, so all right. So for ITP, so there is the development rather of megakaryocytes in the bone marrow becomes inhibited or suppressed. Okay. On the other hand, with IDA, so we mentioned earlier, so the deficiency itself in the iron, okay, suppresses the production, okay, of mature RBCs, okay. And then thalassemia, okay, so you also included it under the absence or suppression, okay. So absence, are you pertaining to the defect in the gene, Miss Yun? That's why thalassemia is under the category of absence or suppression. Is it because of the missing gene or the dysfunction? why is thalassemia under the category of absence or suppression? Miss Yun? Let us wait for the response of Miss Yun. So based on her answer, so based on the answer of Miss Yun, okay, so she chose thalassemia under the absence or suppression category. It's because of the absence or insufficiency of the synthesis of one or more of the globin chains of the hemoglobin. Okay, so that's correct. On the other hand, so for the category overproduction, so we noticed that her answers given were okay. So you have polycythemia, multiple myeloma, and AML. So very self-explanatory, right? So there is overstimulation, overproduction, and unregulated proliferation of the cells. Okay, so these are there is an overlap actually between the category of overproduction and malignant. Okay, so it's actually a very long list of hematological disorders if you're going to categorize these disorders using this list that we have. Okay, now next slide, Ma'am Evir. Now another point of interest of discussion would be the laboratory diagnosis of the hematological disorders or defects. Okay, so we are all familiar with the basic testing parameters that we use. Okay, can we probably get some update? So, what are the current laboratory diagnostic parameters being used for these hematologic disorders? Okay, so of course we have the routine test. So you have the complete blood count, you have your peripheral blood smear examination, okay? But we are also interested in knowing other supplemental tests being done, okay, to establish the diagnosis of these hematological disorders. And also, apart from this, we are also interested in knowing are there current acceptable international clinical practice guidelines or standards for the disease diagnosis? Okay, so this would also include, of course, the nomenclature or the classification of hematologic disorders, especially malignancies. Okay, now in the previous years, okay, during your undergraduate courses in hematology, you became familiar with the classification of anemia of rather leukemias, for example, right? So you have the old French American British classification of anemia, okay? And then I know that you're also familiar with the WHO classification, right, of leukemias. Now, can we want also to look at the standards? What are the uh, list of laboratory tests that should be done to rule out or rule in these hematologic disorders, specifically the malignancies? Now, in the the CPGs or standards. Okay, so it's expected that we will also include uh, those testing parameters that are molecular. Okay, so we also take note of the genes or proteins of interest. Okay, responsible for the hematologic disorder. Okay, but I will not let you present it today because this is kind of, yes, sir, Peter, I agree. So that's the FAB or French American British. Okay. So can you please have some independent research on this? So we want to know the current, okay, updated laboratory diagnostic parameters, and also if there are any international CPGs or standards. Okay, because some of the standards, the older ones, may already become they must have been obsolete already. Okay, and there may be changes in the assignment of classification and nomenclature of the disorders. Now, I want you to look up these current guidelines and standards. Okay. Now, in doing your research, please note that you have to cite your references appropriately. Okay. So please make sure that you include in your references or your bibliography from where you got the information from. Okay. And then the last slide. So in our concept mapping, okay, so we noticed, okay, that as we go about the list of the disorders that you mentioned, okay, there are overlaps, right? Such that some disorders can be classified both as hereditary and acquired. Now, under the malignant category, so those disorders can also be categorized as overproduction. Okay, in aplastic anemia, for example, okay, so it can be both hereditary and acquired. Okay, now this is to show that there are several causes. Okay, leading to these hereditary or acquired disorders. Now, some of the causes that we know of, okay, regardless if it's hereditary or acquired, would be number one, so you have your genetic alterations. Okay, so sometimes it could be a deletion or an extra, okay, or a mutation in some of the amino acids present, okay, in this particular gene. It could be probably that the disorder is chemically induced. Okay, so there is an external stimulus, or it could be brought about by radiation, for example, okay, or medications. Okay. However, some, okay, disorders are remaining, they remain to be unknown. Okay, so there is unknown etiology or cause, or cannot be explained by anything. Okay, so that's another interesting gap. Okay, despite the advances in the technology in terms of disease diagnosis and identification, there are yet unknown etiologies to be discovered. Okay, now regardless if the disease is hereditary or acquired, for example, or benign or malignant, okay, so a specific lineage, okay, of the cell, okay, is predominant. Okay, now in addition to the task, okay, so I give you the first one, right? The first task I mentioned earlier is for you to look up the roles and the functions of the regulatory and modulatory molecules, right? So there is a picture of the EPO. I showed it earlier. So look up for the roles and the functions of the molecules. Okay, and then the other task is the previous slide. Okay, so current laboratory diagnostic parameters and internationally accepted standards or guidelines for the diagnosis classification of hematological disorders as appropriate. And then this is the third one. Okay, so you look up the or you categorize further the lineage of cells affected depending on the category that was shown earlier. Okay, so you have three categories: hereditary versus acquired, benign versus malignant, and then you have the absence suppression versus overproduction. So you create another list, okay, showing the lineage, okay, of the cells affected by the particular disorder. Okay? So do you understand the instructions, sir and ma'am? No questions?
Ma'am, when is the deadline po?
Next week.
Thank you, ma'am.
So and also starting next week, okay, so we will be having the presentation of the hematological disorders. Okay. So were you able to come up with the schedule, Ma'am Sol? So you have a list already, right? I'm giving you the freedom to plot your own schedule. Because I understand some of you are working in the hospitals and you have prior commitments as well. So I'm giving you the choice to plot the specific date that you will be presenting. I just need the updated list with the dates. Can you send it to me, Ma'am Sol? Okay. How about, okay, so the date, you will discuss the dates. Okay, no problem. So please make sure that you include our foreign students, okay, ma'am, in the final list. Okay, so I'd like to emphasize again that it should be coming from a journal. So updated journal article. Okay, so so you have to present a journal showing the selected disorder that you in the list that you're going to submit to me. There should be no overlap. Make sure it's an updated publication. Okay, and then we will be having our critiquing part, Q&A. Now, as you present, so make sure that you also study the basics. Okay, so the etiology, the pathophysiology of the specific disorder that you are presenting. This will become the basis of the Q&A as well. Okay, two presenters per week, Ma'am Sol. Please limit the presentation to 15 minutes per person. Okay. So we also need to emphasize some updates in terms of molecular basis. Okay, so make sure that you include that in your discussion as well. All right. So I will give you the remaining of the time to start your research on the disorder. Okay, so you have to organize your presentation and we will be ready to listen to the presenters by next week. Any questions, sir and ma'am? So before the presentation next week, so I will provide a short lecture. So again, a review um, in terms of red blood cell morphology. Okay, so that would be the discussion for next week, and then we proceed with the journal presentation. Do you have any clarification or question?
Hi ma'am, I have a question po.
Yes, Surgeon.
Ma'am, we just want to clarify if what we will present next week would be the journal of the specific diseases or the entirety of the disease, like the etiology, pathophysiology, pathogenesis, signs and symptoms, treatment, and whatever. And we just have the journal as a supporting basis of the report po.
You will focus on the journal article.
Okay, ma'am. Thank you
But
very much
but
po.
it is expected that after you present the journal, okay, for example, Sir Jem, isn't it that you selected IDA here
Yes,
in the list,
ma'am.
right?
Yes
So
po.
if you have a journal discussing about the IDA, so you present this particular journal article, and then majority of the side questions, okay, will be focusing not just on the journal but on the disease itself. Okay, so we expect that you know the pathophysiology of IDA because we need to highlight the disease also during the Q&A. Okay?
Yes, ma'am. Thank you very much
Okay.
po.
Okay. So make sure you prepare your supplemental references. So make them readily available just in case during the Q&A we have some questions needing to be answered right away. You can screen share whatever answers you have seen based on the references that you used. Okay.
Yes, ma'am.
Right. So if there are no more questions, I will be dismissing you now. So you can start with preparing your journal article. Okay. And you're free to be as creative as you want when you present your journal article. Okay. Yes, Sir Pax.
Ma'am, I wanted to clarify because last week you actually gave us a task on a journal that was published in three within 3 years. So is that the journal that we are supposed to discuss, or is it a different task?
Based on the prior, so 2 weeks ago, I've asked Ma'am Sol to come up with a list of students and then you select the disorders, the hematological disorders that you're going to present. Okay. Now, you need to select a journal related to your topic or discussing your topic. Like in your case, Sir Pax, you have here CML, right? So chronic
Yes.
myelogenous leukemia. So the journal that you're going to present should be about CML. Okay?
And the journal should be like within 3 years published,
Preferably.
preferably.
Yes, because it has to be as new as possible, as recent as possible. Okay? So I am also seeing here the email of Ma'am Sol. So in the list, okay, so the foreign students have already selected the topics. Okay, so thank you for the update, Sir Vincent. So please feel free to send me an email for any questions. Okay.
Hi ma'am, I have another question po.
Yes, Sir Jem.
Ma'am, regarding the last concept mapping that you presented, the last slide po. We are
Yes.
wondering if it is connected to the concept mapping that we did today, just focusing on the hereditary and the acquired categories po.
Ah, you have to include all this time. So you have to include the other categories. Okay, so the last slide that I showed is just an example. So I only gave hereditary and acquired, right, in the slide, but you have to include the other categories. So benign, malignant, absence, suppression, and then you have overproduction. We are interested in knowing the lineages affected. Okay?
Okay ma'am, thank you po.
Okay. So you may now start doing your research. Don't forget to cite your references and prepare for some gory Q&A